to say for section 4.1, this is the back of the worksheet. We're going to find the value of y, and these three problems, 12, 13, and 14, all use the same theorem. This is the triangle exterior angle theorem. I have my packet here. Where is the triangle exterior angle theorem? It's this guy right here. I don't have it marked with a number. I'm thinking this is 4.1. I'm thinking this has to be 4.2. That's my guess. I'm not going to write it in there in case I'm wrong, but I think this is theorem 4.2. You can check your notes to be sure. So we're going to use that theorem, triangle exterior angle theorem. Here's what it says. It says this exterior angle is the same as these two added together. It's just a shortcut. If you wanted to use triangle angle sum to find this angle, you could, and then you could take that angle and subtract from 180 to get that measure. But you don't need to do that whole 180 thing twice. You could just do this plus this gives you that. So y equals 70 plus 88. That's 158. Okay, so if I was to use the terms from the theorem, this is your exterior angle. This is the interior angle that touches it. So these other two are called remote interior angles. These two remote interior angles add together to give you that exterior angle. This one, you actually don't even need to use that theorem. I said that you did, but you don't. This is a linear pair right here. If that's 90, that's 90 because together they add up to 180. This one you can. That's an exterior angle. These are the remote interior angles. So y would be the same thing as 42 plus 20. Same thing with these ones. We're going to find the measures of the angles that are missing. So we're going to use a bunch of different theorems here and a bunch of different ideas that we've talked about in this section. You have a right triangle. So you can use this corollary. The acute angles of a right triangle are complementary. That's the corollary that goes with this triangle angle sum. So when you have that right triangle, if that's 30, you know this guy's 60 because 90 minus 30 gives you that 60. Number 16, vertical angles. If you miss out on these vertical angles, you really have no hope of getting the other measures in these triangles. You have a right triangle here, so these need to be complementary. That's 30. That's 60. That's 30. That's 70, so that's 100 degrees. So that means angle 3 is 80 degrees. Number 17. We got two triangles, and we know these two angles right here. This is 65, that's 45, that's 110 degrees, so angle 1 needs to be 70. I wasn't even going to try to squeeze that in there. Now, here's the other concept that you got to recognize on this one. Actually, you could do this a couple different ways, but I'm going to do it this way. We know that angle's 20. That's this angle. Now, we also know this exterior angle for the triangle that lives right here. It's a 45 plus 70. That's 115 degrees. So if that's your exterior angle, what do you add with 20 to get 115? This guy right here must be 95 degrees. So that angle 3 is 95 because together these two add up to 115. Now, if you know that that's 95 and you know that that's 20, that's the same 115 that we just talked about. So this guy has got to be 65 degrees. 180 minus 115. You'll notice when you do problems like this, you end up doing the same type of math over and over, the same calculations. Number 18, in triangle ABC, angle A is congruent to angle C. That makes this triangle isosceles. Angle B is a right angle. Okay, so that's a right isosceles triangle. Find the measure of each angle. Well, just like we talked about on the other side, there's only one right isosceles triangle in the world, 45, 45, 90. Number 19, this is about billiards. Three balls remain on a pool table. The distance between the three balls is shown in the diagram. So this is a scalene triangle because the distances are all different. Classify the triangle formed by its sides. Well, that was easy. Scalene. Copy the triangle, measure the angles, and classify the triangle by its angles. Okay, so you could do that as well. I think you could just look at this triangle right here and see that this angle is definitely obtuse. The other two are acute. But if you wanted to do what they ask you to do, you could. But I'm going to say that's obtuse because you can see that's an obtuse angle.